Welcome to Lesson 3 of Module 4, Theories and Laws. We're going to start this video by completing our Do Now. Suggest reasons why some scientific theories may be disproved. What do you think would be needed to disprove a theory? So in this inquiry question in particular, we're going to be looking still at the same one, what leads to a theory being developed. But in this video, we're going to focus on how different aspects of a theory can be disproved through the collection of evidence. And hopefully that was the discussion you came up with as a result of our Do Now activity. We're going to be looking specifically at the geocentric theory, the theory of inheritance of acquired characteristics, Dalton's atomic theory, and the steady state theory of the universe, noting that in lesson 2, we also looked at the phlogiston theory, which is one of the theories that in fact was disproved due to the evidence that we now know as the oxygen theory of combustion. And again, we're looking at gathering information and evidence, which we're going to use this time to disprove our ideas. So how does a theory get disproved? Well, first it would have to account with some experimental results being in contrast to what a theory's predictions were. And firstly, we'd have to investigate whether the design itself of the experiment was appropriate. So whether it was a valid investigation, whether it used accurate equipment, whether in fact the results were reliable. And they can confirm these results by replicating the experiment, which is what we know is required to prove a theory as correct, but also in this case disproving a theory. Noting that we have always discussed the importance of keeping accurate records in form of our laboratory notebook. And if this in fact does happen, then there will then become a search for how the theory can be improved. So there may be some minor changes that are needed to the theory, some major changes which may be needed, but none will be made unless there is an explanation that is found that will in fact have the evidence that can stand up to work within the theory's existing framework. So over time, and we see that with Dalton's atomic theory, which we'll get to, modifications build on top of each other, and the theories are constantly improving, and greater predictive accuracy actually does happen over time. And since each new version of a theory must have more explanatory power than the last, therefore our scientific knowledge becomes more accurate over time. So due to all of these modifications, what we now know is the best truth that we have access to. So sometimes what can also happen is that two or more theories may in fact end up combining and being replaced by a single theory to explain how each of those theories would have been more accurate in this case. And in this case, we refer to that as the unification of theories. So we have 4 examples that we're going to be looking at in this lesson. And the first is the geocentric theory, and it was of the solar system. And the idea was that the Earth was the center of the solar system, and in fact disproving that based on the observations made, to know that, in fact, all planets in our solar system revolve around the sun. And it was used by tracking the presence of the different moons and stars in our night sky. And those records actually were used to disprove the geocentric theory. The next is the theory of inheritance of acquired characteristics. And this is what was proposed by Lamarck. And it was the idea that organisms can pass on to its offspring physical characteristics that the parent itself acquires through its lifetime. And that may be due to the use or disuse of different characteristics. What we now know is that, in fact, everything is, in fact, inherited through our genes. And we now know that this explanation that Lamarck gave us in terms of a giraffe's long neck, and therefore that if the parent had stretched its neck during its lifetime to get the higher leaves on the trees, that its child would in fact have a longer neck when it was born, we now know as not the best explanation of how traits are inherited. And the next example is Dalton's atomic theory. And it was the first attempt that the scientific community had seen to describe all matter in terms of atoms and their properties. And therefore, looking at this theory, what we now know about the atom and the atomic theory is in fact based on Dalton's original work, but we know his theory was not completely correct, and we can see his theory written there. And then our last one is the steady state theory of the universe. And it was the idea that the universe is always expanding, maintaining a constant average density, with matter being continuously created to form new stars and galaxies at the same rate that the old ones were. And we have replaced that theory, and it's not the one that is most commonly used, but we're going to look at that in more detail in our activities. So, the transmutation of species and Lamarckism and the inheritance of acquired characteristics were the first proposed theories of evolution. They were not supported by experiments and therefore rendered obsolete by Darwinian evolution and Mendelian genetics, which we can see now as what our most accepted idea of those are. Point 2 of Dalton's atomic theory in particular was rendered obsolete, and that was due to the discovery of isotopes. And point 3 was also rendered obsolete by the discovery of some subatomic particles and nuclear reactions. What we knew about the observations of the night sky made by Copernicus, which we didn't mention in the previous slides, made the geocentric universe made obsolete. And the steady state theory is a competitor of the Big Bang model until evidence supporting the Big Bang and falsifying the steady state was found. So it was the first original theory, but now not having the same evidence that supports the Big Bang theory. We're going to be undertaking a secondary source evaluation with each of our activities because this is based on our secondary source research that we're going to be undertaking to look at these theories in more detail. And we're going to be looking at some of this information. And this is a useful tool that you may like to take into some of your other subjects, but also when you're looking at sources in our upcoming assessment tasks. So remember, secondary sources are things like textbooks, education and government websites, scientific journals and articles, and encyclopedias. We're generally not looking for fiction books or non-educational web pages, articles in popular magazines, or discussion blogs. So we're really looking at, are our sources following this CRAP method? So looking at, is it current? Is it relevant? Is it authoritative? Is it accurate? And what's its purpose? And we'll come back to this kind of scaffold when we're looking at our secondary sources in our activities. So that concludes our lesson 3. Make sure you're tuning in for lesson 4.